All right, today we are in part 2 of section 3.4, solving inequalities using addition or subtraction. Yesterday, we talked about the different types of inequalities that we'll see and the different types of symbols: less than, greater than, less than or equal to, and greater than or equal to. With these, the actual symbol is going to affect what kind of a dot we have. If it's open dot, it's just less than or greater than. If it's closed, it means it has that equal to bar. If it's going left, it means less than. If it's going right, it means greater than. So that symbol tells us how we're going to graph. In example 1, we started to see if I can pull it up. We started to solve these using inverse operations, and we graphed a solution on our number line. So just real quick, would we have done an open or a closed dot on this one? We would have done a closed dot because it's equal to an arrow going right or left. To the right for greater than. On the next one, remember this one was a little different because 1, the answer was negative, and 2, the variable was after the inequality. So the negative goes in the middle again, but what number went directly to the left?
11. Negative 11.
Okay, and then negative 12, negative 9, and 8. Open dot on the negative 10. And which way did my arrow go? Does anybody remember?
Right.
Remember, we tend to think it needs to go to the right, but when we read the variable first, it means that all numbers must be less than negative 10. Less than negative 10. All right, so then the next thing we did was we saw some graphs, and we needed to actually write the inequality that matched it. So because the point was plotted on the 6, I knew that 6 was part of my solution, and it was less than because of the arrow, and that was my final answer because the dot was open. On the next one, my point was plotted on the negative 5, and because it was a closed dot pointing right, I knew it was greater than or equal to. All right, so just picking up where we left off yesterday, now in example 3, we are writing an inequality from a scenario. Okay, so this is the scenario it gives us. When you're driving on the highway, the speed limit is 70 miles an hour. Drivers who go faster than 70 miles an hour are speeding and could receive a ticket. Write an inequality that gives the speeds at which drivers can be ticketed. All right, we're not going to worry about graphing, but we do want to write this inequality. All right, so we need a variable. That's the first thing that we want to use. Now, I used an S. Why? S for what? S for speed. You could do M for miles. Really, it doesn't matter what variable you choose. Sometimes choosing one that kind of fits in with the scenario is helpful. And now I need my cutoff number. What's my cutoff number that it gives me? 70. So we have to look at what they're asking us. They want us to write an inequality that gives the speeds at which drivers can be ticketed. So do they need to be going less than 70 miles an hour or more than 70 miles an hour?
Less.
To get a ticket.
Oh, more.
In order to get a ticket, they need to be going more than 70 miles an hour. Now, what if they are going exactly 70 miles an hour? Can they get a ticket? No, that's not what the problem tells us. So this is my final answer. If I'm going 70, then I'm okay. But if I'm going 71, that cop might not be a very nice cop for giving me a ticket at 71, but technically that is breaking the speed limit, right? Usually kind of the rule of thumb is like 5 miles an hour. More than 5 miles an hour over is when, you can start getting in that danger zone for getting a ticket. All right, so you think you can do one? Yeah, okay, so let's look at another scenario. In this scenario, we have the freezing point of water is at 0 degrees Celsius. Temperatures at or below that freezing point, the water turns to solid or ice. So I want you to write an inequality that gives the temperatures at which the water is a solid. You do not have to graph. All right, so do we have our inequalities? So I used W for water. All right, and what's my turning point? What's my
0.
Yeah, that's my number. Now, does the water need to be less than 0 or greater than 0 in order for it to become a solid?
Less than.
It needs to be less than 0. Can it be 0? Yes, it can. And how did you know that? What word in there tipped you off?
At or below.
At or below. So since it can be at or below 0, it's less than or equal to. All right, so that's going to be my answer. All right, now I'm going to give you another scenario. You're just going to have to kind of listen to it. The weight of a dump truck, a dump truck, can carry up to 1,000 pounds of dirt. Okay, can carry up to 1,000 pounds of dirt. Can you write an inequality for that scenario? All right, so I just wanted to give you one more scenario that we could practice. So it's a dump truck can carry up to 1,000 pounds of dirt. Go ahead and write your inequality. All right, so I use W for weight, and then it's 1,000 pounds. And what inequality did you use? Jenny?
Greater than.
W has to be less than.
The weight has to be less than or equal to. If it's 1,000 pounds, it can handle it, but at 1,001 pounds, your tires start feeling some pressure. They could start popping, or you could have all kinds of issues, maybe even with your engine. So it has to be less than or equal to 1,000 pounds. If it's more than, then we're over that capacity. All right, you have 3 problems like that on your homework tonight. Okay, now in example 4, we actually did already solve some problems like this. I want to change this up just a little. So don't write this problem. Negative 10, actually I need to see the negative 10 is greater than x minus 12. So I'm going to give you negative 10 is greater than x minus 12 plus 5. All right, you're going to have a problem on your homework tonight that basically you have to simplify before you can start moving your numbers. We did this with equations, but I just want to review it since you have one of these on your homework tonight with inequalities. So what do you see that you need to do first? I kind of tipped you off to it, but what do you see that you need to do first? Greg, did you catch it?
The like term.
Yeah, what did you combine?
Negative 12 plus 5.
Very good. So negative 10 is greater than x minus 7. All right, and then we add 7 to both sides. And negative 3 is greater than x. But we need to be careful not to fall into a common, basically, mistake that's often made, and that is to read this as a greater than sign. Because the variable comes after the inequality, I have to still read it first, and I can tell now that all solutions must be less than negative 3. So when I graph this, what 2 numbers go to the left of negative 3?
Negative 4 and negative 5.
Negative 4 and negative 5. Negative 2 and negative 1. And would it be an open or a closed dot on negative 3?
Open.
Open. Going which way? To the
Left.
to the left. So if we just read that, we might think it's greater than, but that's not what it's saying. It's saying that the answer, the number, the solution must be less than negative 3 in order to make the inequality true. So when I plug it back into my original problem, that value would make the inequality true. All right, any questions on that? Okay, so we're going to go ahead and move on to example 5. This is another just scenario type of problem where we have to take the information and put it into an inequality. It says you're competing in a triathlon sports competition that has 3 events. Last year you finished it in 85 minutes. The table shows your times for this year's first 2 events. What possible times can you post in the running event and still beat last year's finishing time? So With equations, we normally start off with an equal sign. With inequalities, that's a little bit harder to do. So what I would suggest is you start off with your total. What's the total minutes
85.
that you see there? Yes, 85. And now you know that you have a total for this year, but it's not completely added up yet, right? It's 17 for the first event, it's 45 for the second event, and I don't know the third event. So now here's my question. Do I want these times to be less than 85? Greater than 85? Can they be equal to 85? What do you think? Don't say it out loud. Go ahead and try to write in your inequality. All right, so I want to beat last year's time. So if I want to beat it, it means that it needs to be lower, right?
85 is greater.
Yeah, it needs to be lower
And not
than 85. Now, what if it is 85? What if it's equal to 85? Then does that mean I beat it?
no.
No, so it has to be actually less than. All right, so now I have 62 plus x is less than 85. I subtract 62 from both sides. And x has to be less than 23 minutes. Basically, going into the third event, I've already done my calculations and I know I need to beat 23 minutes. Okay? We see this a lot with sports competitions, don't we? You know, where it's like multiple rounds. Like, you ever watch the Olympics, like, let's just say diving, for example. So when those divers get up for their last dive, and especially that they strategically order them, so like the first, second, and third place, they kind of go in order at the end. So when that first place diver gets up at the end, he's the last dive, or she's the last dive. They know before they make that dive what they have to get in order to beat their score. So that's the inequalities that, they're dealing with inequalities right there, aren't they? Because they know what they need to score in order to win. So they need to score let's say a 9.0 or greater. You ever hear the commentators saying things like that? So, we see inequalities actually every day. We just maybe sometimes don't think about it that way. All right, so now let's look at graphing compound inequalities. You have one problem like this on your homework tonight. It's going to say something like graph the compound inequality x is greater than 3 and x is less than 10. Okay, so now this isn't a typical number line that we're setting up, because on this number line I have two solutions, so I don't just start in the middle with whatever number I thought was my solution. I need to use the range of the values to determine the range of my number line. For example, which value is my lowest value? 3 or 10? 3. So I need to go a couple units below 3, all right, just to give me a little bit of cushion. So I'm going to start at a 1, 2, 3, 4. I want you to start thinking in your mind while we're numbering this, where I'm going to stop. Doesn't have anything to do with the end of the line either. Did you have 12 in mind too?
Yes.
Or maybe 11 or 13, or where were you going to end? 10? Okay, so we do need to extend it a little bit past the highest value. Okay, so now that I have my number line set up, I want to now plot my points on each of my solutions. So would it be an open dot or a closed dot on the 3?
Open.
It would be an open. And would it be an open dot or a closed dot on the 10? It would be open. Whoa. It'd be open also. All right, now, one could be open and one could be closed, but this just happens to be that both are open. And if it's greater than 3, which way does my arrow go? To the right. And if it's less than 10, which way does my arrow go? To the left. So my lines are actually going to connect. So with a compound inequality, you're just going to make that line a little thicker if they both connect. Now, If they didn't connect, let's say it was less than 3, then I would still draw my arrow this way and draw my arrow this way. Okay? But it just so happens that with this inequality, the only solutions, and this is what it's saying, if I need a number that is a solution to both of these, that's why the word and is there, then the number has to be both greater than 3 and less than 10. The only numbers that are greater than 3, whoops, I didn't mean to circle 3, and less than 10 are these numbers right here, 4, 5, 6, 7, 8, and 9. Those are the only possible numbers that can be a solution to this compound inequality. So, the other inequalities we've been graphing, they had like an infinite number of solutions, right? Well, because this one actually had some endpoints, some boundaries that we had to stay within, there's only a certain range of inequalities that can be the solution. Does that make sense? Had to be greater than 3, but less than 10, so there's only a set number of numbers that are our solution. And if you understand that, that's everything you need to know for 3.4.